So we want to talk about mechanical ventilation today, but when we do that, we want to start with our basic mechanical ventilation, which everyone is familiar with, which is the bag valve mask with PEEP valve. With this bag valve mask with a PEEP valve attached, we have everything we need to mimic the ventilator. So when we're talking about mechanical ventilation, we have two components. We have the ventilation, CO2, and oxygen, your O2. So the way we accomplish the ventilation part is our tidal volume, how much we squeeze into the patient's lung per breath. In addition, we also have respiratory rate, how fast we squeeze the vent. Those two combined will make up our minute ventilation, which is how much flow of air is getting to that patient in 1 minute. The way we measure this ventilation is through our end tidal CO2. That's going to be the most common way we're going to see. We can also get hints based on the PA, the partial pressure of arterial CO2, or the partial pressure of venous CO2 on a blood gas. That can give us some direction. In addition, we also measure the FiCO2. This is a measure of dead space, and dead space takes away from our minute ventilation. On our oxygen side, we have the port where the oxygen tubing attaches. We can titrate that up to pretty much 100%. And we have our PEEP valve, which we can dial in, anywhere from 0 to 20 centimeters of water of PEEP. Those are going to be how we drive oxygenation of the patient. Specifically, what we're measuring is going to be the SpO2, the little finger probe. We can also get clues based on the partial pressure of arterial or venous O2 as well, based on our blood gas. This may trigger us to titrate down on the PEEP or down on the FiO2 of our bag. And again, everything we have right here on this bag valve. We're going to talk about the exact same things with the ventilator. So, the ventilator is going to act in the same way we use to set up our bag valve mask. The same things that we use, the same tidal volume, respiratory rate, PEEP, and oxygen are going to be the same components that the ventilator uses, with the added safety bonus of the patient's gender and height to make sure that the ventilation is not going to do harm to the patient. Typically, this is the setup mode you're going to see on most of your ventilation patients. Again, you're going to control your tidal volume, just like you would the amount, how much you're going to squeeze that bag valve ventilator mask, as well as your respiratory rate, how many times a minute that patient is going to get a breath. In addition, your oxygen is going to be controlled by the FiO2, just like hooking it up to wall oxygen, and your PEEP. And then we'll start the ventilator. With adaptive modes, they will take between 5 and 8 breaths to reach a steady state, so you may get alarms when you initially set up a patient. This is to be expected. Wait the 5 or 8 breaths and allow the ventilator to adjust. And as it adjusts, as we can see, we are getting a tidal volume, a VTE, here, and a minute ventilation here. Again, these are going to be what we're going to use when we compare to our charts. This is what we set. This is what the patient is actually getting. The other number you'll notice that is very important in a ventilator is our peak pressure. This is a way we can prevent injury to the lungs that is not available on our standard bag valve mask. And remember, patients' tidal volumes are going to be between 6 and 8 cc's per kg. So what we are actually getting may not be the same as what we are expecting to put in. Therefore, we're getting an alarm. We can still be within the 6 cc's to 8 cc's per kg, and the alarm has gone away.